morning everyone. Today we are going to discuss about the flight dynamics instability of Airbus A330. This is the failure due to high altitude stall. This can be discussed as a design thinking along with the students. So based on the student views, the design thinking approach can be used and solve this issue, and we can also understand the flight dynamics importance of stability and control in very high altitude around 330 hundreds like 30,000 feet altitude, how this crash has happened, and this can be solved using design thinking while empathizing all the parameters which is involving in structural impact, aerodynamics impact, as well as the propulsion impact, which all consolidated together, which can help to understand the flight performance and its crash can be discussed here. So here we are taking the Air France 447 crash which has happened in Atlantic Ocean in 2009. So that can be discussed here. So we'll start.
Aerospace department. I'm here to talk about what happened in Air France 447. So the Air France 447 was flying from Rio de Janeiro to Paris. So during cruise, the pitot tube iced over, so the airspeed readings became unreliable. So the autopilot was disengaged. So pilots had to fly in the aircraft manual. So here the confusions were started. So the pilot put back the side stick to increasing the angle of attack. So here the aircraft exceeding into critical angle of attack. So the aircraft entered into the storm. At high altitude near around 30,000 feet, the aircraft was operating near the coffin corner. The coffin corner is like a narrow zone between the stall speed and the critical Mach number. So it is very difficult to recover from the stall. So as the stall begins, the aircraft is very difficult to generate lift to the recover from the stall. So the aircraft thrust is lower and the aerodynamic controls also will be sluggish.
The flight data shows that the aircraft almost stalled for 4 minutes. The nose kept on pitching up. For example, the pilot tried so hard to keep the airplane stable, but the data shows that in that 4 minutes, the flight just descended down without any stable or balanced motion, which means that whatever the stuff the pilot tried to do, like pulling up the pitch, he failed, and even worse, the stuff he did, the pilot pitching up made it even worse and made the aircraft fall descend gradually, and then in alternate launch mode, which is a mode in that aircraft, the aircraft just the flight control
Start.
In alternate launch mode, the flight system no longer in alternate launch mode, the flight system shall no longer have a stall protection, which means that whatever the pilot made the input, gave the pull-up input, it didn't work and therefore failed.
Partially a human factor issue. The pilot blindly trusted the faulty airspeed indicator instead of checking the stall cues like buffet, high pitching and altitude. So the So the crash was not about the aerodynamics but the pilot's situational awareness and training. If the pilot has pushed the nose down and reduced the angle of attack, the recovery might have been possible even at that altitude.
Excellent analysis, guys. So here we are understanding that flight dynamics is not only the equations and the static margins studying of the flight. It also helps to understand how the design thinking helps to understand the failure of Air France 447 aircraft crashed in the Atlantic Ocean in 2009. So here we are taking some key points like stall can occur at any altitude, also in not only in takeoff and landing, it can also occur during high altitude, and also we can understand how the flight mechanics helps to understand the different aircraft performance during takeoff and landing as well as the level flight. So thank you.